So now we'd like to go the other way. So we want to move the RIP routes as an OSPF export. Now you can see we're going to have some issues here. On router 5, it's going to be fine because we can basically just move the RIP routes, we can export them. Because when they come to router 3, they can be SSA area ranged together. However, on router 6, if we were to export these RIP routes, they're going to leak through. And that's because this NSSA area range, this command here on router 6, isn't able to do the redistribution and the range at the same time. It's just too close. And so here we see this pressure we're talking about on router 6 going towards OSPF as well. If we're redistributing the RIP into the OSPF, it's not going to be possible to range them together at the same time. So we need a solution a little bit similar to the other direction. What we're going to do, we're going to put a second aggregate on router 6, and only on router 6. Router 3 doesn't have this issue. The type 7s can reach router 3. Router 3 can NSSA range them together without a problem. So we're going to put an aggregate on router 6, 172.30.32.0. Notice it's the same as the area range that we'd like. Okay, and then when we come to redistribute the RIP out of the OSPF, we're actually not going to take the RIP. We're going to take the exact aggregate. So on router 6, the policy is set policy options, policy statements. We're calling it RIP to OSPF so that it matches router 5, but in actual fact, we're taking the aggregate here, 172.30.32.0/20. We're going to accept it, and we're going to advertise that out. These externals that are in OSPF from router 5, they're still flooding through, and router 6 is going to leak them through. So what we're going to do is we're also going to set the area range on router 6 as well. NSSA area range 172.30.32.0, because even though router 6 isn't able to range its own type 7s, we want it to be able to range R5's type 7s.